video he's going to introduce?
Yeah, he's got an intro.
welcome to Manufacturing Live. Today we're going to do some really cool robotics and automation. We actually got Mariah Sampson here. She's at Wichita State. Mariah, tell us a little bit about yourself and what you got going on today.
So I'm an industry process consultant for Delmia, heavily focused in the robotics, and right now I'm in our lab here at Wichita State. It's a partnership with NIAR, which is kind of their research arm. So they do a lot of research, they perform what ifs, they do some contracts out for companies.
So you started your career out as an aerospace engineer, right? Can you tell us a little bit about the journey that got you from aerospace engineering to Wichita State and running the robotics lab?
Yeah, so I started, I went to Embry-Riddle. They sent me a really cool packet and, super hyped up. Probably one of my favorite things in that packet was it really is rocket science because they produce one of the largest classes of aerospace engineers. And so, that's everything from planes to rockets to stuff that goes into space, stuff flies through the air. And so I was like, yeah, I'm going to be an aerospace engineer. And I got there, and the first few classes, it's fun, it's engineering, you got your basic physics. And then I took a CATIA class, actually, and one of the projects was to take a plane, make an improvement on it, change out the engines, add wingtips, all that fun stuff, and then do an analysis. And in that class, they taught us the basics of aerodynamics. And I just remember sitting there and being like, this is so boring. And, I'm surrounded by all these people who love airplanes, and they could say, hey, that's, a Boeing 747 flying through the sky, and it's this big. And I was like, I don't know if I can do airplanes. This is terrible. And so I went and switched that class. They had aerospace engineering and they had mechanical engineering. So I was like, okay, I'll do mechanical engineering and I'll pick the robotics track because I like to move things. I like to see how things work. With robotics, you can see, your process immediately instead of, hey, in 10 years I might be able to see that plane. And then I just kept taking engineering classes and I loved it. The robotics classes always made sense. The labs made sense. Seeing your inputs taken into either a vision system or just how a industrial robot moves, it made me fall in love, and I just stayed on that track.
You guys did some cool robotics projects, right? Like when you and I were down at Titan's place for Boombastic earlier this year, you were sort of talking about some of the cool robotic stuff. Can you talk a little bit about some of those projects you did with robotics when you were in college?
Yeah. So it started my freshman year. They put us in engineering 101, and we had to play with some of the Lego robots, which sounds, pretty simple, but it was my first exposure to making robots. And that we had to, take a bunch of ping pong balls and put them in a certain spot, or sweep them all up, and whoever got the most got, the prize for the class. And then, we went to the robotics lab where we're doing vision systems. So we're mapping rooms and we're doing path planning from that. So it's avoiding obstacles and you're seeing how that works. And then my capstone project, we actually decided to build a six-legged robot. So we were supposed to go to competition for this, and it's supposed to walk over obstacles. So they just throw a bunch of junk on the floor, and the robot has to walk over the junk. And it was really cool. We did, sheet aluminum, so sheet aluminum and 3D printed parts, and put it all together, and it's six-legged, and it was really fun.
Okay.
Yeah.
That sounds really cool. Way different than my experience, but it sounds a lot cooler. It does seem that as we're talking here, Mariah, just a little bit, I'm going to pause a little bit between our discussion because I guess the internet's being a little funky today. But so you go through school, you get into mechanical engineering, you like the robotics component, and then how does that get you to Wichita State and the NIAR building and Dassault Systems? Can you explain a little bit about that process, like how you ended up here?
Yeah, so like a lot of college students, I was furiously applying for jobs as I was getting closer close to graduation. And I actually temporarily work for a company. They do a lot of contract work. So, someone needs something modeled, they don't have the person, so they send it to this company. And so I was working there for a while, doing some healing on aerospace or airlines, the airplane skins. So they get like a model in, and it's all, I don't know, someone just didn't know what they were doing, or it was scan data, one of those. And then a little while into that, I got a call from Dassault. And they offered, I'd interviewed with them, and then I didn't hear back for a while, and then they offered me the job. And it was just, I came out here to do an in-person tour or an in-person interview, and the MRAM in the NIA Robotics Lab, it's this big, giant 6-robot cell, with robots that are twice the size of a person. And it's just seeing that up close was exciting. I don't know how many people have ever seen a big industrial robot move, but when they start flying and you're like, people can't move that fast. And this is just throwing things in the air, and and I just was like, that's where I want to be.
Okay. I mean, it is sort of like a symphony, right? When you watch how the robots move and they're all going together, it's a little bit of an artistic point, right? When they're all in sync together.
Yeah, and it's artistic, and it's exciting, and it's hard to comprehend until you see it up close. And
yeah.
you can see videos all you want, but I don't know. I just always like to be in person with the robots.
Yeah. Yeah, it's fun to have the hands-on component, right? Like that's the best part of combining virtual and real, is being able to actually go out and see the results of everything that you do. So it looks behind you, it looks like there's a little bit of a robot cell set up. Can you sort of explain a little bit about what that cell is there? Because at NIAR, you do a lot of proof of concept type stuff there, right? Like you show how the real world is actually supposed to be.
Yeah. So with Dassault, we're a software company, right? And so a lot of, if you go to Fanuc's factory, you can see their, lights out factory, and you go in and they turn the lights on and the robots are there. So a lot of our stuff is done virtually. And like I said, seeing something on a computer screen isn't super exciting. And seeing something in software and us telling you, hey, we can do this, we promise, but we can't really show you because all of our customers, have pretty strict NDAs, and they don't want other people seeing what they're doing. We decided to build our own cell. So it's pretty simple. We're assembling a gearbox, but we did everything end to end in the software. So we have, the plant layout. We took a 3D scan of this room, and we replaced everything. So we started building, so we don't have to make our own floor. We developed a process plan, and we pushed that process plan to the robot program. So now, you have the robot program in the virtual and what's running in the real, and you can see that live instead of, we promise we can program the robots, right? You can actually see what's reflected on the screen. And then that also through execution, because we have a Prezo, which is our MES system, and you can push, it does everything an MES system does, but it also connects with the platform and allows the workers to do the work instructions. So you have, your work instructions, your tracking, making sure everyone's meeting metrics. And we showed that all here, and that was the purpose of building it. Okay.
Now, when you do, I'm learning about some of the robotics with the virtual and in the real, obviously myself, because I know how they work in the real world. I've been around Pendants, I've been around the programming, but when you go through the robotics process and you connect like the virtual component to the real, like there's a little bit of a process in there, right? Like you have to, like, you can design it in virtual, but then you have to mate it to the real to make sure everything's correct. Can you talk a little bit about that? Because I think there's sort of a misconception on how that whole process works, and I think it would benefit a lot of people to understand that.
Right. So it's kind of a multi-step process, and we like to sell it's super simple, push and play. But anyone who ever works trying to make that integration, like, you can't really push and play anything, even if you're doing it from a teach pendant, right? You have to be there. And so you start, the simpler the cell, the easier it is. And so if you just have a robot cell, a robot in the cell, you can just upload a program. It can be a blank program from the robot controller into Delmia, and that'll automatically map all of your controller settings. And then that allows you to create your program in Delmia, push it out to the robot, and upload it to the controller. So you can do that either over a network connection if you have access to the robot over the network, or you can use a USB into the teach pendant. And then if you need to do something like calibrate, we have calibration tools that are just a least squares calibration, which you can do touching off points from the product or part. Or we can do super complex calibrations. So like the MRAM, you have 6 robots that all have one world frame. And they're all on rails. So not only do you have 6 robots that are trying to do this world frame, you also have to calibrate the rail. And that process, we have the calibration tools. I won't get too far into that just because it's a whole, it took us about a week, which isn't bad. But at the end of it, we got within like 1,000th of an inch of our point on, again, robots that are on 30-meter rails.
Yeah.
Or 30-foot rails, sorry. Switching mega units. But so you want to calibrate to make sure you have a digital twin. You create the best fit first. You calibrate. You get an actual virtual twin. So what you do in the virtual will mimic what should be in the real. And then you can upload and download programs from the robot controller.
Okay. So there's this part of the reason for the calibration, right, is because when I design it in my CAD system of choice, and it's all perfect, right? But then when they go to install it, there's the tolerances of human interaction of installing it differently than what the CAD model shows. So part of the calibration process, along with how it moves in the motion and inertia, is making sure that wherever that position is in the real world is exactly the same position in the CAD model. So there's that adjustment back and forth that happens when you first, I guess, what they call commission a robot. Is that right?
Yeah. Yep.
Okay.
First set up cell.
Okay. And then when you were talking about uploading the program, like if you, let's say you had a welding cell that's been there for 15, 20 years and you have a program that works, but you want to optimize it, you could basically take that program, upload it into the software, and then you can optimize based on that. But what you're getting is not, like when we think CAM, we just think XYZ moves, right? Or maybe ABC, depending upon the complexity. What we're talking here is like the acceleration, deceleration, all of the things that the robot has to have to know how fast and efficient to move. That's what you're getting with that type of program, right?
Yeah. So you're getting the speed, you're getting the acceleration, deceleration, you're getting, you have a 6-axis robot, you have 6 degrees of freedom. So that's X, Y, Z, yaw, pitch, roll. In addition to sometimes some of those movements are joint moves. So it's just saying each joint goes here. Some of them are positional moves. It's saying go here. You have to plan your path, right? So is it a linear move, so it just goes along a straight line, or is it a joint move, so it just does whatever it wants and ends here? And yeah, so it's a little more complex than machining.
Yep.
And there's a lot of information that each move has, and that's even before you add in, is it a welding move? So now you have to start the weld, and here's where you end the weld, and maybe it's a skip weld, so you go along this path, and or it's a rivet, so here's your rivet profile. So now here's how you have to install this.
Yeah. And then if like the cell that you have behind you, then that one's even a different world because there's human assemblers around there while the robot is also doing it, right? So that's the next component of sort of the cobot type relationship with humans and getting clearance and motion. So can you talk a little bit about that cell that's behind you for assembling that gearbox?
Yeah, so this cell, it has an industrial robot, which is the ABB, that I'm pretty sure you can see in my picture. I can't see what you see.
Yeah, go to the left just a little bit. There you go. Now we can see them.
Yep.
Yeah.
So that white robot there is an ABB. It's just a small industrial robot. And I couldn't reach that unless I hopped up on the table, right? So we have that away from people. And then the UR, which is the blue robot back there, is a collaborative robot.
Okay.
So that it moves a little slower. It's supposed to go into the space of people. And around it, I'm not sure if you can see it, there's that yellow.
Yeah, the light curtain.
Yep. So there's a light curtain here.
Yep.
There's actually a mirror right here, so we only have one set of light curtains, and they protect all along where the robot is, so you can't reach in on both sides.
Okay.
And so what happens is the UR can go outside of the space, but the ABB can't. So anyone who's going to touch the, less safe robot is going to break the light curtain, and this whole cell stops. Whereas the UR goes out, it picks up the kit that we make, and then it places it back into a human work zone. Okay.
And the whole work cell on that workflow is it's an assembly of a gearbox as an example, right? That's what we built there. Okay.
Yep.
So go ahead. Go ahead.
Oh yeah, it's supposed to be fairly industry neutral, something that is complex enough so that you can see all of the components and how things come together, but also simple enough that we can bring customers here and they can get hands-on if they want to assemble or see how the work instructions work. Okay.
I do want to remind anyone, if you do have questions, please log in, ask questions. Mariah is one of our, robotics experts, automation experts. We'd love to hear some thoughts you have. Now, you have the virtual twin of this, and I think you have a touch screen behind you, right? So could you sort of show maybe we can get this to work, I'm not for sure, with a video of how that's working. We'll see if we can do a screen to a screen here.
Yes, and can you see the screen okay?
Yep, we can see it. Oh, the table rolled back there.
Oh, fine. Okay, we're gonna try that. Let me actually pull this forward just a little bit. Seems like it's not wanting to stay. So let me know when you can see the screen.
Yep, we can see it.
Okay, perfect. So we kind of went through a whole workflow, starting with systems. You have the engineering design. So, modeling it. So this isn't something we made, but it's something we had to reverse engineer model. So we actually, NIAR has a reverse engineering lab, and we got their help. They did a scan of the outside of the gearbox, and then we created models based on that.
Okay.
And then, doing a simulation analysis, we're not using this for any component, but if you had loads on it and you said, we want it to perform at this rate or this speed, you can, get all of that. And then, of course, we created, all the plant layout for the cell. So you're taking that cloud of points that I mentioned, you're clearing out some of the area as needed, you're placing the cell in there. And creating it that way. And then you're going through the process planning, right? So how do we assemble this?
Okay. So when we set this up in NIAR, we actually went through the whole process of what a customer would have to do, right? It wasn't we just jumped to the cool, fun stuff at the end. We went through and did the process planning. We did the actual scanning of the building.
Yep.
So in that scan, I guess for me to understand, so in the scan data that we have just the mesh of the room, and then we were able to swap out some components with the real things that we want to interact with, right? Is that what we did there?
Yeah, so what you can do is you can import the scan data, and that's as is.
Okay.
And if I might real quick, you'll notice there's some TVs kind of by the stairs.
Yeah.
And we took those out of the scan data. Right now, if you can see that, that's where those TVs.
Yep. Okay.
So we, were able to clean that up and put the cell where we wanted it. We're able to add the robots as needed, and position everything and make sure that we have the room. And then this video, if you'll give it just a couple more seconds, you'll be able to see that process. You just create a box, you say, I don't want this here, you cut it out, and then, you have your layout.
Okay. So you can scan everything and then just choose what things you want to interact with, and the rest is just there for spatial awareness more than anything.
Yes. Yeah, and that's, we use a company called Navis, and we didn't just scan this room, we scanned the entire building, which is, 4 more rooms just like this, in addition to hallways and classrooms, and there's 2 stories. Okay. And it took an afternoon.
Oh, wow. Okay, that's a lot faster than I thought it would be. Okay. Yeah. I mean, to me, that's pretty cool, right? Because a lot of times, like, in my previous life, we would have modeled all that up in a CAD system and it would have taken forever. And you get to the point where it's like, there's stairs, we'll just hack some block in. And it's never as accurate as it probably should be.
Well, and not only is it not accurate, but, some person on the shop floor all of a sudden decided they needed a table in the middle of the room. So now you have a table that you don't know is there, and you put a cell there, and you're like, now we have to move this table or cell or shelving, whatever it might be.
That makes sense. Okay. So what you have in the virtual then is the work cell that's behind you is like what I consider the legit CAD model with all the kinematics. And when we're talking about motion and kinematics, coming from the Solidworks side, we're talking about like supermates, right? Like when we assign a pivot or a rotation, like it's not just so I can click and drag it, like that has all the information to know how to efficiently move. So if I drag a robot out, it knows that they need to move in a certain order to maintain the kinematics, right?
Yeah. Yeah. And so what we do actually is our R&D goes through and they create the kinematic models for almost all of the major industrial robots. So anytime ABB releases a new robot, someone goes through and they create the model for you, and that automatically has all that information. So it has the speed information, acceleration, the kinematic change. So some robots have stabilizers, some robots aren't 6 joints, some of them are only 4, some of them are 7, and so it has that movement information there, so you don't even have to define it.
Okay, so really your responsibility then is just making sure the end effectors and those things are in the right spot, and then just doing the programming and the motion, right?
Yeah.
Okay.
Pretty much. So yeah, you can drag it around, you can create programs, do what if scenarios. So maybe you want to decide between a small robot or a slightly larger robot, because obviously, the smaller the robot, usually the cheaper it is.
Right.
And so you're able to do that analysis and make sure that everything's able to reach.
Okay. Okay. So like what you have in the background there, that's the actual virtual version of that cell that's running in the real world, right? So you're seeing the cobot and the ABB work together. Yep. So when you program, we have we have a universal and we have an ABB, right? How does that work from programming them? Because they're 2 different machines with different requirements. Like, what's the process for that? Because to me, that's the part where it gets confusing. Because as a machinist guy, I just work on one machine and that's it.
Right. So it's actually pretty simple, and that's really what Delmi is good at. Is I can create the robot programs for ABB or UR with the same interface. But when I go to push the program out, I use a different translator. So we have translators for ABB, we have translators for UR, as well as, like I mentioned before, any of the major manufacturing brands. Okay.
So the actual programming of the robot is the same regardless of the type. And then instead of post-processors, it's a native language that the robot uses, correct?
Yeah, we use translators. So
Okay. I'm used to the posting world where we do FANUC and Siemens, and and then we just do all the different settings. It's a little bit different. So.
And then if you're used to using a Teach Pendant or you're used to programming in the native robot language, we also offer the ability to program with a native robot language editor. So if you don't like the Delmia interface, it allows you to just type in whatever you want in that editor. So lots of options.
Well, it looks like we may have got a hiccup there in the connection. We'll wait just a second. But if there's any questions that anyone has right now, please go ahead and jump in. We'll wait for the connection to come back. It looks like we may have a hiccup here. So if there's any questions, please jump in, ask any questions. We'll try to answer them, and we'll wait for Mariah to join back up with us here. There we go. Looks like Mariah is back now. That was quick.
Okay. I didn't lose you guys, so.
Okay. Well, we might be showing too good of stuff, and someone cut in and took our connection here. So, so you were talking about the Teach Pendant and being able to write your own code. So they can basically go into an editor, do what they're used to doing in a Pendant, and then that stuff still translates into seeing how it's going to interact virtually. Yeah.
Yeah. So you're using a native robot language editor, or a native robot language teach is what we call it, and yeah, it looks more similar to what you'd be used to if you're programming the robot.
Okay, so explain this part to me. If I have a cell and I've been using a Pendant, why would I be interested in doing something virtual like this? Like from your perspective of what you've seen, why would I do that? Because I can just use what I got.
So you could just use what you got, and honestly, if you're going to keep playing the same program over and over forever, just use what you have. It's not going to help you to have a virtual cell if you're never going to change anything, right?
Okay.
But if you are changing programs, if you want to perform some analysis, so, how do I optimize this cell? So I'm bringing it in. What can I change movements? Maybe I don't need that there. You can perform some what-if analysis, as well as if you are changing your programs, you want the downtime to teach a robot on a Teach Pendant. I have on a very limited basis. So I've used Teach Pendants before, not as experienced as a lot of people on them, but to me, I think it's really tedious. Because you have to jog to the move, you have to play it, you have to play through each movement to make sure you're not hitting things. Whereas Delmia, I click on buttons, I can create points in space, so I can easily just jump to that move, it's super accurate. And then I can play through it at 16 times speed. So I don't have to play through it super slow. And I haven't taken the robots offline in order to do so.
Okay.
So still able to run. I'm able to program while you're running on the shop floor, as well as if you have any types of changes and you just want to see how they impact, that's useful as well.
Okay. I could see the taking it offline. In a previous life, I worked for a company up in Nebraska that robotically welded mower decks for like Exmark as an example. And every time they'd give a new revision for a mower deck, it would take an entire shift for them to program with a Pendant to weld. And then you would still end up probably scrapping 2 or 3 of those because of the fact that the welding wasn't at the exact angle as it rolled over the edge of the deck for the weld. So I can see the value of not taking it offline. I was curious from someone who does it every day versus like my casual observation of when I used to be around them on the floor. The other thing, I guess, too, and I'd like your thought on this, is like in that cell behind you where you have the universal robot and you have the ABB, if you were going to program those with pendants, you would have to program each one with their own pendant, and then where they interact and overlap, don't you have to move them to the correct positions and then record those simultaneously? So you're doing both at the same time on 2 different pendants? Would that be right?
Yeah, it would be a lot more work if you're doing it that way, because like you said, you'd have to be doing each of them separately and then choreographing them together. Okay. And that people do it all the time. It's been done. People teach robots to interact, but it takes a long time. And it takes knowledge of both robot languages and controls.
Okay, makes sense.
As well as, you have to have a knowledge of the PLC, because now you're probably also calling those programs from the PLC, and you have to check it that way as well. Okay. So in that cell behind you, there's some human stations, right? So can you talk a little bit about what that assembly line actually looks like? Because I'm curious about the automation part. We've talked a little bit about the robots, but I'm curious, because there's human interaction there. Can you explain how that cell actually would sort of work if there was people there assembling? Yeah. So let me do my next screen. So this is an old version of the cell. We had a presentation that we needed done as soon as possible, so you'll see some of the outdated versions. And so what's happening here is she's using work instructions that are on a touch screen to be able to see what she needs to do. And at each of those stations that you're interacting with, you have the work instructions. And the full process, what ends up happening is you start in the robot cell. The operator pushes the button to go, the robots come, they do the first half of the assembly. And then for some of the more complicated steps, like inserting the worm gear, so that, because you have to kind of wiggle it around, it's not a precise, you just stick it in, we send that to the human stations. So we do the simple stuff on the robot, complicated stuff using humans, and playing work instructions so that they're guided through each of those steps. As well as on the last station, once the assembly is done, the operator can call the robot to do a quality test. So what happens is the UR comes down a rail, it picks it up, it puts it in a test station that will read the gear ratio to make sure that you're within tolerance. Okay, so the robot's taking some of the easy stuff on the front end. Then we have the human doing the more specific humans type stuff that has to happen, right? And then at the end, it does a quality check. So really, the human interaction is reduced, but we're still on each end keeping automation to ensure consistency. Yeah, and part of the robot doing the quality test as well is you're having some pneumatic. Losing my mind. The test station has some pinch points. You're holding it in and rotating it super fast. You don't want a person standing right next to that. Yeah, that makes sense. There's a safety component there. Yeah. Okay. So what was the most fun part of doing this whole cell and putting it together? I think being able to see something being built from the ground up. So, because a lot of times when I go in, there's already a cell there and I'm just mimicking what's already there. And being able to say, well, this is what I want, and, this is what we're going to do, instead of having to be, at everyone else's whims because it's already there. And seeing how it can be built, and also seeing how everything comes together, because you don't get to see that often. A lot of times in the software we work with, I'm Delmia, so I do Delmia stuff. I do the robots, even within Delmia, I just do the robots. But seeing, how you go from your M-bomb all the way through to your execution, I think that was honestly the most fun for me, is seeing it come to life. Getting to be part of the big picture versus here's this one little slice that I have to take care of. Yeah. That makes sense. I'm that way too. I like seeing the bigger picture and having a little bit of control over all of it versus just sitting down and doing one cog in the system. So that makes sense. So you have all these cool toys and these cool things at NIR.
what is the coolest thing you've done there as far as automation, robotics, those things? And I shouldn't call them toys. I know we have some mini ones there. Those are the toys, but like the big cell, like what's the coolest thing you've done?
Probably working with the MRAM cell, which, like I said, it's a 6 robot cell, and probably a tie between doing the calibration on that, because, you know, it's kind of something I was like, this isn't going to work, and then seeing it work. And then also, we had a customer visit, so we had a real-life application. They wanted to compare their current process for assembly to, which is using only humans, to how they could do it with robots. And getting a, you know, real-life relevant product, and seeing everything come together and building up all the tooling, developing a process. And what's really cool about that is NIAR, and specifically the robotics lab, Brian Brown, in charge of that, he likes to talk about the art of the possible, right? And so his goal is to create robot tooling as low cost as possible. So we had a Cleco gun that was a Cleco gun you can go get from anywhere. And he made a fitting so that the robot is using a human Cleco gun to insert Clecos, and you have a 3D printed part, it attaches to the robot. Because a lot of times people are like, oh, I have a robot, I have to spend, you know, hundreds of thousands of dollars in tooling for it.
Yeah.
And seeing how you can build up that same stuff for, you know, a lot cheaper and with what you already have.
Okay. So
seeing all of that, I think, is the most interesting.
Yeah, I mean, that to me, that sounds awesome. You mentioned something there. So the NIAR building is open to businesses, right? To come in and see how things work. Can you explain a little bit about how that works? Because, you know, we have lots of customers that aren't that far from Wichita State. If they wanted to look at robotics and automation, can you explain a little bit about how that would work?
Yeah, so there's different levels of engagement. If they want to come in and work with Dassault and NIAR, you can do that. So you can do a tour, you can see all of the facilities, see what's going on, and then decide if you want to partner. So that's probably the easiest, the simplest. You get to see everything, and you don't have any obligation. And then if you want to see just how our software works, we actually have what we call the customer collaboration room, and it has 8 stations. Let me backtrack. There are actually 3 customer collaboration rooms, each with 8 stations that have all of our software loaded. And so if you want to provide some proof of concepts that way with just the software, you can do that. And then if you want to get into building something out or seeing a proof of concept, like I talked about the customer with the NIAR Robotics Lab, then you would, that was a 3-way contract, so they were working with us and we were doing it virtually, and then we were working with the robotics lab to actually implement it onto a cell. And it's not limited to just robotics, although there is the robotics lab. There's also reverse engineering, you have additive manufacturing, as well as just general assembly. And then depending on what you want to do, a lot of times they'll do proof of concepts, whether it's just, you know, they were doing an evaluation for a customer on different AGVs. So they were testing, you know, a few different AGV models on how well they would work in some pretty harsh conditions in the factory. And then they print out a report on that. Or sometimes they're commissioned to build robot cells. So they build and program the cell and then send it to the customer.
Okay.
So it's kind of a, you know, pick what you want to do, and they'll make it work.
Okay. So like the cell behind you, if someone wanted to come see in person, like how that would work and how the setup would be and understand in person, you know, they could come down in IR and chat with you one-on-one and, you know, get a little bit deeper understanding, see how it would apply to their stuff, right?
Yep. Yeah.
Okay.
So they were always open for tours. There is some, you know, you have to manage the logistics of that, but we welcome customers to come through. As well as something cool about this cell is we own it. So if you want to do a proof of concept, you want to say, maybe I want to put something in there. So now you want to do the process plan and develop the robot programs for your own product or something else. And you want to change it so that table right there has pattern holes. So you can change the robot layout, you can add tooling, you can add fixturing that you want, and build it up as you want. So you can come here with your own proof of concept, which is the other part of the intention for this cell.
Okay. So you do have something cool coming up in February. You're going to be there in the shop floor with me. You want to talk a little bit about the robot you're bringing?
Yeah, so I'll bring a small UR3 robot. It's, about that big. I'll pack it up in a bag to bring it with me. And what we'll be doing is creating a cell where you can input. We haven't quite decided what we're allowing for input, but maybe names, maybe initials. And then it'll draw it out for you on a piece of paper, and then you can take it home. So you'll input it using an interface we'll build with control build, which is kind of what dummy robotics is to PLCs.
Okay.
Right? So we'll program all the logic within control build. You'll input within control build, and then you'll be able to see what the robot's doing live in the virtual world.
Okay.
So you'll see the real robot running on your input, you'll see the virtual robot running on your input, and you get a takeaway of whatever you've decided to draw.
Yeah, so there'll be some really cool interactive stuff. Mariah will be there, so if you have robotics questions, you can ask her all about that in IR in the cell. I will say we are also going to have a little bit bigger robot doing some other things. It'll be all enclosed. It won't be quite as interactive as what Mariah is building, but we're going to have some cool stuff this year. I can say now that SEMA is over, the Factory 5 supercar will be there, and we'll all be building stuff on the shop floor for the supercars. So if you are interested in robotics and you want to pick Mariah's brain more about this and how it can be implemented, and just ask about automation, she will be at 3D Experience World, so I would recommend you should probably go, because she is a wealth of knowledge. I got to spend a week with her at Titans of CNC Boombastic, and I was blown away at how little I know about automation. I thought all my years of running CNCs, I thought I had a grasp on it. I don't. So if you can make it, I would definitely recommend making it. But at the same time, if someone wanted to get a hold of you before then, Mariah, what would be the best way for them to contact you? Reach out to the NIR building and then ask for you, or what's the best way to contact you if they want to come down and have some discussions about automating?
So I am on LinkedIn. You can contact me there, as well as if you just send me an email. It's mariah.sampson@3ds.com. So both of those, I try to stay on top of my email. LinkedIn, I log in at least once a week. So either of those options.
And I guess the one thing we haven't talked about is one of the cool things about these solutions, and I'll say the dummiest solutions in general. So I'm going to generalize them, whether it's machining or robotics or any of those. The data that comes in that you can leverage is CAD agnostic. And that's one of the cool things about that, and some of the things, I don't want to sound sales pitchy because that's not my goal here. But one of the points of the 3D Experience platform is it doesn't just have to be CATIA or SolidWorks. You can actually work with any of the CAD data, step by just any of those, which is pretty cool. Because if you're just looking to automate, you don't have to go through a bunch of steps to get there. You can just take the CAD data you have with a scan of your building, and then we can start automating, right? I mean, to me, that's the easy part, right?
And, just to expand on that, we have chunk grippers in the cell right now, and we use those all the time. And I don't know how many times I've gone to their website and just downloaded a stat file. And so I'm using the manufacturer's gripper model.
Yeah.
It's simple.
Yeah, Shunk is awesome, by the way. Those vices we saw down at Boombastic, where they just drop them on and they locate, and you can just pull them off. I was blown away by that. So that is a good point, that you can go to vendors' websites and download that stuff and just use it. So with that, we're coming up close to the end of our hour here. What do you see for the future? What do you see where we're going, what the future of automation and robotics is? Why would someone want to get into it? Your thoughts on that.
I think, we're going to see more and more automation as things get advanced, but there's always going to be things that people are going to do better than robotics, right? So that's where a lot of the collaborative robots come in, or maybe if you're not even using collaborative robots, collaborative cells using stuff like, light curtains and safety sensors, so that people can work closer with robots and really automate the tasks that are too dangerous for people to do, right? Yeah. There's a customer who assembles giant batteries, and they wanted to evaluate how they could take a robot into that cell instead of having two people there, because one person has to watch in case they electrocute themselves, right?
Yeah.
So taking the dangerous jobs away, but also you're not taking the dangerous jobs away, you're just allowing people to do a safer job, right? So instead of programming the robot, now you're able to step out and program it virtually. And instead of being right there, touching the dangerous stuff, you're supervising the robot doing it. You're making sure that it's done right. Yeah. And really, I think that we'll see more automation, and hopefully it's going to be so that people are safer, so that you're taking, like I said, you're taking the dangerous jobs and automating them and enabling people to do the safe jobs. And it's really, I like robots. They're everywhere. Automation is everywhere. Anyone who has a phone knows that. You have Google, which remembers all of your passwords across all your platforms. So now I just have to log into Google, and now I can access all of my accounts everywhere anyways. Yep. So.
Yeah, I mean, you no longer have to spend all those years being an expert in the floor to be able to do this one thing, right? Like, right. It's a little more, it's gamified, but it's not, because you're doing real technical stuff. But by doing it in the virtual, you get to go through a lot of what ifs, and there's less risk of, here's a $100,000 robot. If I move this the wrong way, I'm going to crash it and ruin a $2,000 end effector. There's all this stress, right? Where in the virtual, I can do all that without the risk up front.
And not only that, we're not seeing a huge replenishment of people wanting to work in factories. So yeah. How do you get more people interested? Younger people, because a lot of manufacturing is people who have been in the industry for 20, 30, 40 years. Yep. So how are you going to capture that knowledge and be able to reuse it, because those people are coming up on retirement?
Yep. Yeah, and you just made me feel really old, the 20, 30 year part, because I'm past the 20 year. But you have a very valid point. All the people that I learned from have retired a long time ago, and all of a sudden there's this big gap, and they're looking to fill that gap with knowledge. But like, normally I wouldn't personally be looked at as someone that knew what I was doing at 20-year mark. I would have to be at the 30 or 40. But because of that gap, you're forcing people to fill that quicker. So behind me, it's even worse, and that tribal knowledge gets lost. So I agree with that completely. And I think, like what you mentioned in the beginning, you started out in aerospace engineering, you got there, you were doing great, you realized, hey, this is really cool, but it doesn't really fit what I want to do. But you were able to find something that gives you that hybrid virtual real role, right? And I would assume, again, not knowing, but I would assume that a lot of people are looking for that. And if they don't get lucky enough to find it or have it introduced to them, then they oftentimes choose maybe a position that they're not happy with, that isn't fulfilling. I don't know if you saw that when you went to school, but it seems like I've heard those stories a lot.
I think I've heard that, but I also think that, I went to a school that was pretty specialized. I mean, the full name of it is Embry-Riddle Aeronautical University.
True.
And people who go there because they love planes.
Yeah.
And they did a really good job of getting people hands-on. So you're talking with people from the industry. And really, I think just exploring what you like. There's options out there. I've seen people be very unhappy with their jobs, but people also, don't want to explore. They don't want to take chances.
Yeah.
I moved from Arizona to Kansas for a company that I thought CATIA. They're like,
Yeah.
oh, Dassault Systèmes. I honestly called it Dassault for the first 3 months I worked here.
Yep.
And I'm pretty sure I did it in my interviews too. So,
Yeah.
and then I get here and I'm like, oh, this isn't CATIA. And it's just exploring opportunities and taking those chances instead of, well, I have to stay here because, now I'm in Arizona.
Yeah.
So.
Yeah, I agree with that. I mean, I started out in Nebraska. I live in Colorado now, so I can understand that. You have to follow that you have to follow the passion that fits where you want to be in life. I think that's the key. So between now and 3D Experience World, what are you working on? What are you doing here before we wrap up? Any cool things you're doing in the next couple months before anyone gets to meet you?
I'll be working on a customer project, doing some calibration so that they have a work cell they can play around with, as well as working on operations experience, which is one of our new solutions, and it kind of allows input from the shop floor that you can see in the virtual, so that you can kind of troubleshoot and diagnose issues sooner, right? So
Okay.
being able to have a visualization of what's going on in real time, as well as being able to reverse through that and see all that information, and then kind of just wherever they throw me. So I moved to a new team early this year, and it's been a lot of here, learn this, and then learn this, and work with this person. So nothing set yet.
Which that's how we came to work together, right? So I mean, it's all good. It sounds really exciting. It sounds like you're not stuck behind the desk, which is pretty cool.
I enjoy it. I like having new things to work on all the time. I would probably go crazy if I just did the same thing every day.
Yeah, I'm right there with you. I mean, later today, I'm going to go out and run my machines here. So I'm 100%. You and I are on the same wavelength of you can't just sit behind the desk and gain knowledge all the time. You got to get out and experience it. So with that, we're coming up on the hour. Mariah, I can't thank you enough for helping us out here, explaining robotics. I learned a lot. I really look forward to the cool thing that you're going to have with the cobot at 3D Experience World. I can't wait for us to get there. So thank you so much for joining us.
All right. Thanks, Mike.